Management of electrical hazards. Faulty or damaged wiring or equipment. Loose connections. Use of underrated wiring or poor quality fittings. Lack of earthing, grounding, bonding. Lack of protective safety devices. Use of overrated fuses or jumpers. Working on live equipment. Water seepage or handling with wet body parts. Poor housekeeping. Handling of electrical equipment by incompetent person, lack of awareness and training. Lack of safe working procedures and poor communication. Failure to use appropriate PPE and tools. Lack of warning signs. Lack of proper identification. Arc hazards. Arcing faults in oil-filled electrical equipment, for example, oil-filled transformers and circuit breakers, have an additional component of hazard and risk. Arcing faults within the enclosure or tank can result in a burn hazard from hot oil being expelled from the unit. This is due to overpressure created by expanding gases from the arc energy. The overpressure can result in either a tank rupture or pressure relief. Devices operating, and hot oil can be expelled in all directions in the immediate area of the unit. The hot oil can ignite when it exits the unit's relief device or ruptured tank and contacts oxygen. Burn injuries or fatalities may result from the burning liquid igniting anything with which it comes in contact. Shock hazard. Proper design, installation, and maintenance of equipment grounding, earthings and bonding are critical to managing shock hazards. Mandatory requirements for managing the mechanical integrity of grounding, earthings and bonding. Temporary electrical connection procedure shall be followed accordingly. As a minimum, all portable tools and appliances, temporary wirings and extension cords operating at a voltage 24 volts and are subjected to rough service and are routinely plugged and unplugged to an earthed electrical power system must be protected by permanent or portable RCDs or ELCBs. These devices must have a 30 mA maximum current setting. Battery-powered tools. Reduced voltage equipment. Double insulated equipment. Shrouding and barriers. Insulated or voltage-rated tools. Voltage-rated personal protective equipment, for example, gloves or hats. Insulated mats on floors. Insulated, flexible barriers for exposed equipment parts. The procedures and practices should include but not be limited to the following supplemental elements. Identification of multiple voltage sources inside cabinets. Segregated voltages to prevent accidental contact where multiple voltage sources exist in one unit. Barriers. Insulated, voltage-rated tools to minimize the hazards of accidental contact. Labeled back feeds, temporary feeds, and dual feeds. Identification of the use of common or borrowed neutrals. Static electricity hazard. Static discharges can be an ignition source, and injuries may result from a person reacting to a static shock. Examples of process operations that may have static electricity hazards include but may not be limited to handling or transporting liquids, solids, or gases in portable containers or piping systems. Certain maintenance activities. Bonding and earthing between source and receiver of the product handling system, pipelines, distribution system, spray painting and sandblasting. Minimizing the use of non-conductive materials. In the case where certain processes require the use of non-conductive materials, for example hoses, containers, conveyors, anti-static materials shall be used, for example anti-static rubber belts, steel braided hoses. Use of anti-static PPE. Bonding of pneumatic tools and air removers, blower. Control of flow rate of static-prone materials. Use of anti-static additive in jet fuels. Avoiding splash filling in tanks. Avoiding water contamination of hydrocarbons. Explosion hazard. Guidelines to safely manage explosion hazards that result from arcing faults in electrical equipments in non-hazardous atmospheres. Provision and maintenance of drawings and documents describing the limits of the hazardous area and its classification. Selection and procurement of electrical equipment appropriate for the area classification. Installation of electrical equipment so that it does not compromise the area classification. Maintenance of the mechanical integrity of the installation, including grounding and bonding, wall penetrations for cabling and electrical control rooms. Methods to exclude other potential ignition sources from entering the area. Maintenance of the mechanical integrity and calibration of explosion meters. Control and maintenance of safety interlocks.
Please give comment and suggestions.
Thank you.
Subscribe our YouTube channel and hit the bell icon for more updates. Thank for visit our channel. See you next class.
Thank you.